Good afternoon. Welcome to the I4 Energy seminar. I'm Sasha von Meyer from I4 Energy. Welcome to all of you here at UC Berkeley and those of you watching online at UC Davis, UC Santa Cruz, UC Merced. Pleasure to have you here. And it's my pleasure to introduce our speaker today, Kevin Dasso from PG&E. Kevin is the Senior Director of Technology and Information Strategy at PG&E. He has over 31 years of experience in the gas and electric utility business, including engineering, operations, construction, and asset management. He's currently responsible for developing and implementing strategy and policies for the utility related to the smart grid and transmission and distribution technology integration. He leads the company's smart grid team involving the electric operations, customer care, energy procurement, and information technology departments. So he's someone who understands the policy and the technology. Kevin is an electrical engineer with degrees from Iowa State and Santa Clara University. He serves on numerous bodies, including the WEC, Reliability Policy Issues Committee, former chair of the NERC Planning Committee, Reliability Assessment Subcommittee. He's an advisor on numerous research and academic organizations. I've had the pleasure of meeting Kevin through his work on the Policy Advisory Committee for the California Energy Commission's Public Interest Energy Research Program. Kevin is a very well-respected person in the industry who knows smart grid from many different directions, so it's a great pleasure and a privilege to have him here speaking to us today. Thank you, Kevin.
Well, good afternoon, everybody. It's a pleasure to be here this afternoon. So I'm going to cover kind of a full range of things that we're doing here at PG&E, and I'll just kind of hit the highlights on a lot of the things that we're doing, and I want to be sure that we save some time at the end for question and discussion. That's actually always the most fun time for me, so I get lots of good ideas and thoughts about what you're thinking, what's of interest to you. So let me go ahead and get started. And I'm never quite sure, where everybody is with respect to smart grid, and so I have some very basic things that I'll cover initially, just to be sure that we're kind of all on the same page and level setting here in terms of what do we mean when we use the term smart grid. I've been working in this space for almost 5 years now, kind of back before smart grid was cool, I still get questions. What the heck is the smart grid? So we'll talk a little bit about that. What PG&E is doing now, and some of the things that are next. I thought, just given a lot of interest these days in renewable resources and integration, I wanted to share a little bit about what's happening there, some of the things that we're seeing, and also to give you some pictures of really, what does this really mean in terms of grid operations. I know some of it is conceptual, but we've got some nice data, I think, to share there. And then last, one of the other topics that's always becoming of more interest lately is energy storage. So I thought we'd talk about what is PG&E doing and what are some of the opportunities there. So that's the agenda. And I think we've got, I'll plan on maybe about 30 minutes, and we'll try to save 15 minutes or so for Q&A. All right, so first thing, just some very basic level setting here. As Sasha mentioned in the introduction, I've been in this business for 31 years, so I got all the gray hair here. Kind of when I started in the business, it was pretty straightforward. It was like cost, reliability, and that applied to really across the board, whether you were doing transmission and distribution systems, whether it was power plants, energy supply. I mean, it was kind of a two-dimensional type of thing. In the last several years, we've sort of added a dimension here, and that is environmental sustainability. It's been an issue here in California in many ways for a long time, but a real focus, particularly on the supply side, over the last 10 years or so, with a focus on bringing more renewables into the mix. So So now we're balancing three things. So you've got the kind of the traditional cost, reliability, but you also have cost, environmental sustainability, reliability. And so how do we deal with all of that? And at least one of the tools we can use is kind of this concept that we call the smart grid. And I don't know what you think about that, whether that's a helpful term or not a helpful term. I'll say that in the kind of initially, I think it was helpful because it was a term that people could get their head around initially. It's like folks that aren't really that familiar with this industry could say, well, we have a grid and we should make it smarter. That's a good thing. And so we got we were able to overcome some inertia and get some momentum on working on some of the stuff that we've been working on for a while. We'll talk a little bit about how we think that is changing. So again, very fundamental here, just get some basics. So this is kind of a picture of the existing grid, or the grid that we've had for a long time. Kind of on the on the left-hand side, we've got our central station power plants. I mean, that's been in place for a long time. Now, there's a lot of technology changes have occurred in that space, but that's generally that's how we deliver actually most of our energy today. We've got a transmission system, a distribution system, and then our customers. Again, very stylistic here. The grid was designed primarily to deliver energy from central station power plants to customers. Customers were viewed simply as a consumer, and so everything was designed to flow in one direction. Now things are changing, right? So we've got large central station power plants that are renewable. So I was just talking with one of my friends in our energy procurement organization. We have a 550 megawatt solar plant that's in commissioning now. So the other day it was up to 200 megawatts on its way up, and so we're starting to see that's changing there. And again, one of the other aspects of the grid is it was designed for controllable resources to manage that. Now we've got resources that generate kind of whenever the energy the source is there. So the wind is wind's blowing, sun shining. And we also have things on the other end of the grid. So we've got consumers with solar rooftops. We've got electric vehicles that are coming into play. Energy storage, we'll talk a little bit more about that. That's kind of coming into play. And then you really kind of tie that all together with communications and kind of technology and so on to bring that together. So sort of a concept of how the grid is changing. One of the other things in the kind of the early stages here was the notion that we want a smart grid, so we must have a dumb grid today. Well, the reality is our grid did what it was designed to do. It would move power from the central station to the customer's demands very well. Depending on where you are in the country, the grid delivered that 99.97% of the time. So it was highly reliable and very effective. It did the job that it was designed to do. It's just that job is changing. So quickly, kind of another perspective here on smart grid is it's not a replacement of the grid. So kind of down along the bottom here, we've got the picture of the existing grid infrastructure. When we talk about smart grid, it's not replacing that. It's adding a layer of computing, telecommunications, sensing to make that grid smarter, to act differently and take advantage of new inputs and drivers. One of the other, this is kind of a lesson that we've learned here at PG&E in terms of thinking about how you go about implementing a smart grid. One of the other things I have to say in the early days of working in this space, I got a phone call from a consultant who was working for a policymaker in Sacramento, and it was all the buzz. Smart grid was a ton of hype about that. And this person called me up and said, "Has PG&E ordered its smart grid yet?" And I said, "No, we have not." It's a journey, right? So it's a process that you go through. There's not necessarily an end state here in mind. So as we think about that, we really want to focus on this. We think of this as sort of our virtuous circle here. You think about standards. You really have to work on standards because things have to interoperate. They need to communicate. We want to test things. We believe we have really only one opportunity to make a good first impression with our customers. We want to make sure that before we put something on the grid, before we put something in a customer's home, it actually works. and does that. So we've built some lab capabilities to do that. And then we move to pilot. So we put it out with 5,000 customers or on a distribution feeder to really test it out. And if that all plays out, then we move to a targeted deployment. You can't kind of get ahead of yourself in this space. And so this is our general approach to smart grid. Now, this is a kind of a slide that gives you a very high-level overview of some of the areas that we're focusing on here at PG&E. So I'll try to make this now a little bit more real. So the first couple of slides were, well, here's the concept, here's the basic, what do we mean by that? And I want to tell you about some of the activities that we're actually doing now. And we've put together this construct to kind of help organize things. Because, the smart grid concept really covers end-to-end the grid. It's not just the grid, it's not just customers, it's not just meters, it's really the whole ecosystem. And so when we think about this, we've kind of divided it into three areas. And the first being our engaged consumers, and I'll give you some examples of the things that we're doing in that space now. Smart markets, so we are active participants in energy markets. We've got lots of people that are joining energy markets, kind of in that previous slide. We have customers that are getting into the generation market by owning a rooftop solar power plant. We've got demand response programs that are engaging consumers. So we'll talk a little bit about what's going on in that space. And then a smart utility. So what are the things that the utility can do that will provide benefits to customers in terms of reliability, outage management, efficiency of the grid itself. So that's kind of how we've organized some of those. And I'll give you a couple of examples in each area. So in the case of the engaged consumer, the first thing I wanted to touch on was this concept of the green button. How many of you in the audience have heard the term the green button? All right, well, this is great. That is unusual, I have to say. Well done. So the green button is a concept where, and this is virtually all of these are enabled now because PG&E has deployed smart meters for just about all of our system. We have about 9.6 million smart electric and gas smart meters deployed, and now that you have that that infrastructure, you can begin to provide data and provide services that we couldn't do that before. So the green button is really all about providing in an industry standard format the energy data that customers that they're generating. We can go online, or you can go online if you're a PG&E customer today and see your energy usage from the smart meters the day before. So today you can go look and see what did you use every hour yesterday, how much did you pay, if you were part of a time of use program, how much were you paying during, how much did you use during peak, off peak, all of that. So you can see that, but what the green button does is it allows you to actually download that in an industry standard format. So you go to the website, click on the green button, and it will provide that data to you in a format that you can share with other providers. Now, this whole space is just developing. There's not that many people that are consuming this data. There aren't that many apps out there yet, but some of the things that we've seen are like solar developers, or customers are trying to figure out, is solar going to be cost effective for me? So they've got some apps where they can download the data, send it to the solar company. They run the numbers on it and say, here's the kind of payback that you might expect to see. So it's really getting access to that type of data. In some cases, so we got people that have done that. We have 100,000 customers that have kind of clicked on the green button. So there's some demand, kind of self-service type folks. Others we're pushing out. So we're taking data and comparing that. So we're giving them their energy usage compared to their neighbors or compared to consumers that have the same size residence in their area to say, oh, you're doing better than average. You got some issues. And then things that you could do to actually improve. So we're kind of pushing that out. One of the other things I want to mention is the energy alerts. So those of you that are familiar with the energy, kind of the energy industry here in California will know that we've had a strong push for people to be very efficient with their usage. And so we've set up a pricing structure so that the more you use, the more you pay. And again, encouraging you to not get into the higher levels of usage. And that's done in tiers, so it's kind of blocks, depending if you're a residential customer, if you use a certain amount of kilowatt hours, you pay this. If you move into this next range, you pay that. Well, with, again, the smart meter data and the interval information that's available, customers can sign up for some kind of an alert that says, well, we can send you a text or an email, give you a phone call to say, hey, if you stay on this current pace, you're going to find yourself in this high tier, with enough time to actually do something about it and adjust your usage. And then the last thing I'll touch on is a home area network. So the smart meters that we've deployed, and typically around the country, around the world, they have two radios in them. One radio that basically communicates back to the utility. The other radio that can be used to set up a network inside the home, a little bit like a Wi-Fi type of thing, and can connect with devices that are called home area network devices. So an energy display that can tell you real-time what's going on. So we're now, if you go onto our website, we have about, I think, a little less than 10 devices that are approved. You can basically go buy those devices at Home Depot or Lowe's. Give us a call, and we can help you couple those with your smart meter, and you can begin to get data for that. So we're starting to, again, make things real and not just concepts. So in the case of smart markets, there's just a couple that I wanted to touch on, and I'll cover some of these a little later. The first one is pricing. So we have one of the largest residential time-of-use pricing programs in the U.S. It's a voluntary program. We have 80,000 customers that sign up for this. Essentially, it's different times of day, you pay different prices. And we can offer this because we have now the meters that can actually track that and provide that data back to you. So 80,000 customers that have been participating. There is almost a 95% return rate. So that every year you have to sign up for this. Customers sign up, and 95% of them sign up again next year. So clearly they see benefits. They like it. It's easy to use. And so we've looked at it. On average, these customers are saving 8% on their summer energy bill, which is a pretty big deal if your energy bill is $500 a month in some of our, like it is in some of our areas. And from a demand response perspective, we'll give them some communication to say, tomorrow is going to be a smart day. Be aware of that. And these customers have been able to reduce their peak demand by 13% on about 15 smart days over the course of the year. So, again, it's a tool, and we're expecting to roll these types of things out much more broadly going forward now that we have the infrastructure. A couple things I wanted to talk about with respect to that smart utility construct. We're currently in the process of deploying, and we have deployed we're calling it an advanced distribution automation scheme that will essentially automatically detect when we have a problem on a section of our grid, isolate that down, and restore service to all the customers in the unaffected sections. Today, for the most part, that's a manual process. Let's say we have a car hits a pole outside of a substation. The circuit breaker opens, clears that, so it's safe. The lines are de-energized, and then we send people out to go find it, isolate the problem, and restore service. On average, that can take anywhere from an hour to 2 hours, for customers to be restored. What this system does is basically, again, it isolates automatically and restores service to customers in sections that are unaffected. So it goes from what we have seen is that it goes from about 2 hours on average to 2 minutes for those customers that can be restored automatically. It does this, it reports back to our operators, and then the operators can do some additional fine-tuning. So customers will see a momentary outage as opposed to a long-duration outage, which we think is a significant improvement. The other thing I'll mention is kind of the tie with smart meters in our outage management solution. We in the past, in order for us to find out about an outage, we relied on customers to call us, and so they would call us up, and our customers were actually pretty good about calling us when they had a power outage, so we would find out fairly quickly. But rather than relying on that, we actually now have the meters that will essentially tell us. As they're going out of power, they communicate back to say, hey, I'm out of power. And the nice thing is that we're able to use that data to much more precisely figure out where actually is the outage, which customers are affected by that. The other thing that we can do is once we, in the process of restoring service, we found that we can, now it's a manual process today, we're looking to automate it in the future, but our operators can ping or can basically go out and test to see if this meter has power or not. And in the past, we really didn't have that visibility. So we believe we saved about 6,000 truck rolls last year. So we're sending people, we've avoided sending people out to things that we thought were out of power that really weren't. This year already, we've saved another about 1,500 truck rolls. So we're definitely starting to see benefits from a cost perspective, an environmental perspective, a safety perspective, all of that. Plus, probably the key is that our most critical resources during an outage event are those first responders, and they're not chasing phantom outages; they're going to real outages, and we're able to get reliability improved in that regard. So those are some of the things that we're using on the grid side. So that's what's happening now. So these are being deployed. We're using them. They're growing, expanding. Some of the things that we have on the drawing board. We have a couple of programs that have just recently been approved for the utilities to participate in. We've got 4 pilot projects. One that I'll touch on is of this voltage and reactive power optimization. This helps us manage our grid in a way that will actually save customers energy. If we can lower the voltage on our grid, customers' appliances will operate more efficiently. They can save energy. Plus, we can operate our grid better, so we can take losses out of our grid. So we're basically going to be piloting these projects, testing them out, and kind of following that virtuous circle that I talked about. The other is a new program. We refer to it as EPIC. It is basically a program for the utilities to do some technology demonstration and deployment in some of these new spaces to see really what's next. What are the areas that we could focus on next? More to come on that, but a lot of opportunities, I think, for leveraging the infrastructure that we've put in place already. So that's kind of basically what's PG&E doing in the smart grid space, what's happening. I kind of flew by that. Again, we'll save some time for questions so you can drill down on any of that if you'd like. But kind of the key message, the one message I would leave you with respect to that is that we're moving from really smart grid as a concept to smart grid as a reality in a way that is benefiting our customers, both in terms of saving money, in terms of operating the grid more reliably, and integrating renewables more efficiently. So again, it's becoming a reality. It's not just a concept. I'm going to talk a little bit about renewables and DG. And some of you in the audience, I've worked with you before. You've seen these slides before. But again, I want to try to make it a little bit real for folks. Hopefully there'll be some interesting insights here. So the first thing is renewables add some significant, variability is probably the best, one way to think about it, but creates some challenges for the grid operators as well as our energy procurement folks. So this picture here on the left-hand side, again, a picture that's been around for quite a while. This is essentially 1 month's worth of data from one wind farm. And every color there is a different day in the month. Same wind farm, same location, different power outputs. Now, if you look at the average, kind of the dark blue line, the average looks pretty good, right? Piece of cake. What's so hard about that? Well, every day you need to deal with that. The second slide over to the right is the power output from a solar array that PG&E has in the Davis area, just outside our Vaca-Dixon substation. It's a 2-megawatt array. What we have is sort of the power output in the amber color there is a nice, clear, sunny day, which we get a fair amount of in that location. The hash, kind of the blue hash lines are what that power output looks like on a cloudy day. Just to give you, some sense of that.
Why are the peaks then? You said on a sunny day it's bell-shaped curve, but in a cloudy day there's sometimes when you're actually getting greater.
they spike up. It's transients. They overshoot. So they spike up past that. The other kind of get a couple of pictures here. This is a picture courtesy of the ISO of on the top here. We've got sort of one day, 24-hour period. The blue line is kind of the dark blue line here is the output from a 150 megawatt essentially wind farm. The maroon or red line is the output from a 24 megawatt solar array, essentially on the same day. So what you see is, and this is fairly typical of California. I didn't bring the chart here, but the wind energy is actually the highest at night, and then drops off during the day. Solar, of course, output is the best during the day, and drops off in those evening periods. So on one hand, you look at it and say, well, it's generally okay. I mean, together they might be a reasonable combination. However, so that's kind of 24-hour period. The chart down below just shows that same set of generating units on a 1-hour basis. So if you look at the solar, for example, probably a little hard for you to see this, but we vary over the course of this 1 hour from maybe a 20 megawatt. I guess this works. 20 megawatt output here, right around 3 o'clock in the afternoon, to kind of increasing up to about it's about, the scale's over here. It's about 6 megawatts, jumping up to right around 18 megawatts over the course of that 1 hour period. So again, not anything new, but some real data to kind of give you a sense of what it is that folks are trying to deal with here. During this hour, this basically is a little snapshot. It's a snapshot of this hour period here. That's what this picture represents. So during that hour, it was fairly stable. The next slide, this is courtesy of the ISO. There's a lot of things going on in this slide, and I'll just kind of walk you through it carefully. On the dark blue line, actually, I'll start with the green line. So the green line is the wind output. And this is an assumption. This is kind of a forecast out into the future that the ISO did using profiles of wind energy and solar energy that we have in California connected to the ISO grid. Assuming we have about 4,000 megawatts of solar and about 6,000 megawatts of wind. That's basically what this picture is depicting. So in the kind of the green line is the wind output following that profile that we talked about on the earlier slide. The amber here is the solar output from that solar, kind of that 4,000 megawatts of solar spread across the service area. And the blue line is actually the combined. So when you add the two together, that's basically what the net generation looks like. So the combined output from that set of power plants. The challenge, and I'll again show you a little bit later, and this is the issue that folks I think are really getting a much more precise understanding of, is these ramping periods. So I'll show you actually on another slide what does the load look like, or what does the demand look like. But basically, you've got over this early morning hours, you've got kind of this ramping down of the wind, and so you've got to be sure that you're offsetting that ramp down with some kind of flexible resource. And then you've got this ramp up in the morning hour, so 8 to about 9:30, 10 o'clock or so. You've got this ramp up, and then again in the evening you've got another ramp down as the solar starts to drop off. So the key for our operators is to manage those ramps. So over the course of this, you've got a 2,000 megawatt ramp down in the morning, and then another 2,000, and then a ramp up. And then another 2,000 megawatt ramp down in the evening. So again, kind of a complicated picture here, but this is actually now what we've done is taken that same basic slide, this basic curve, not exactly the same thing, but we've now put the demand. So this blue line is the demand curve. So in order to basically meet demand with this combination of variable resources here during this period, you've got kind of this 8,000 megawatt ramp in about 2 hours. So you've got power plants that have to pick up during that period of time. You've got about 6,300 megawatts of ramp down. So again, you're just trying to balance generation with load here during this period, and you've got the generation dropping off and generation picking up. And then you've got now over here, again, you've got a 13,500 megawatt ramp up in 2 hours. A fairly significant challenge for power plants. So you've got to have that flexible resource. Now, this is just a scenario. These are some of the things that we're working on as an industry here in California as to how to do that. So, energy storage, flexible resources, those are all flexible resources, meaning primarily natural gas-fired power plants that can come online, drop offline fairly quickly. So I'm going to shift gears, talk a little bit about distributed resources, and I'm just going to give you a picture of the distributed generation that PG&E has in its service area, and how this has changed over the last few years. And these are just customers that are participating in the net energy metering program. So as of right now, we've got about, switch over, 745 megawatts of rooftop solar in our service area. That's total, both commercial, industrial, as well as residential. On the residential side, this is comprised of 72,000 customers that have rooftop solar in their service area. So it's been increasing, and it's continuing to grow exponentially. We connected about 15,000 customers last year in our service area. We expect probably 20,000 this year. So it continues to grow, which is a good thing, on one hand. On the other hand, the grid was not designed to absorb these types of resources going forward. And on the distribution side, and this will be my last slide in this area, one of the challenges that we have is managing voltage on the distribution system. When the PV units are generating, they tend to push the voltage up kind of beyond the limits, both on steady state and also can create flicker. So as you saw that kind of that intermittency as the panels were coming on, coming off, that can cause spikes in voltage. So you see voltage flicker as well as steady state kind of voltage rise. And so we need to be managing this curve so that customers that are in the vicinity of this distributed resource aren't going outside the bounds of the voltage requirements. So these are some of the challenges that we're working on. For the most part, these are just beginning to emerge now for us. We haven't had a huge impact on that, at least at a steady state level. We're doing some work. We want to find out more about what's actually happening at a much more granular level here to understand better how we should be managing this. So that's our distributed resources. And then I'll talk a little bit about some of the things that we're doing with energy storage. Again, kind of making it real. We have 2 large battery projects that we're in the process of implementing. In one case, alongside, or actually at the substation where we have that 2 megawatt solar array I talked about, we have a 2 megawatt sodium sulfur battery that's been deployed. We've run it through its paces, and we're getting ready to actually test that in a real live environment to see how does that tool help us manage some of the resources. And we have a 4 megawatt project that's in construction. We have a ribbon cutting here in May that's located right next to, just coincidentally, a battery manufacturing plant. They manufacture batteries for laptops, but right outside of that site, we're going to have a 4 megawatt battery that will be able to test, power quality benefits and various other other concepts here. Excuse me? This one is basically in our Vaca-Dixon substation. So it's a substation right along I-80. Are you familiar with that?
By Davis.
Yes, right by Davis, right on the way there.
I didn't realize they had a battery.
Yes, it's a little hard to see from the freeway, but it's back in the earlier slides I showed kind of what does that look like, and it's fairly innocuous. It looks just like a bunch of other equipment.
How large is that 4 megawatts? And its batteries?
How
How big?
big? Let's see. It's about. It's in containers. It's about the size of this stage, and approximately about the height of the screen. So pretty good size. It's basically all these little battery cells stacked up together inside these in these chambers.
And the plant, how does it store energy? These are just going to be battery storage facilities?
Yes, they're batteries. I mean, they're just basically batteries with the solid state controls and the ability to actually manage those and charge and discharge. And I'll show you a little bit about that in a second. And the other is that they're pretty high density. So these are 2 megawatt, 14 megawatt hours. So basically we can dispatch, and we've shown so far in our early testing, we can get about 7 megawatts or about 2 megawatts of output for up to 7 hours. So it's a pretty long-term, durable, high energy density solution. So that's nice from a long-term perspective, particularly like an outage management and riding through voltage or momentary interruptions and so on. And it's also quite fast because it has solid state controls. We're able to turn it on and turn it off quite quickly. So this is a simulation. This is one of the things that we want to test with this battery. So we've taken that graphic that I showed earlier. This is the kind of the output from our solar array on a cloudy day. We're looking to program our battery to essentially track that. So essentially offset, and whether we really want this curve or not, we haven't decided, but we want to see, can we recreate the curve that you get out of that solar array on a nice sunny day by essentially charging and discharging your battery in order to offset those ramps up and down and those spikes up and down coming from the solar array. The second is, this is this will be my last slide, and we'll open it up for questions. Kind of an interesting idea. So this is that same solar array. This was January 15th. We're looking to develop, some of the actual tests for our battery there. So this is that solar array. The amber line here is that's the actual output. It was not a really cloudy day, but kind of hazy, perhaps in the morning. Is all that was burning off. This is a more typical output that you'd expect, from that solar array. So you've got these spikes up and down, and we'd like to see, can the battery basically follow that? And the one thing that you notice is you don't have to have 2 megawatts of battery output in order to potentially, smooth this curve. So you may be able to get away with a lot less in terms of energy storage. Energy storage is very expensive. So trying to figure out what is the optimal size, what's the way in which you might operate that battery so that you can, in fact, make that curve desirable from a power output perspective. How can you shape that curve? So these are some of the things that we want to test with respect to that. So again, we've moved. A lot of people are talking about batteries, and a lot of people are talking about energy storage. We have them, and we're beginning to run through those tests so we can get to see real life types of opportunities. And with that, I'm going to stop with my presentation. We've got about 10 minutes, I guess, for Q&A. So I'll open it up. Anything that would be of interest. So great questions along the way. I appreciate that. That's always helpful.
Great. Let's give
so
Kevin
what would you
a
like,
round of applause.
anything you'd like to talk about? All right, great. It's all fair game, and anything I didn't cover is fair game as well. So.
I may have missed it, but could you say a bit more about third-party use of customer data?
So with respect to providing it to third parties? Okay, so from a privacy perspective, this is a very important thing. Our Public Utilities Commission has established rules for how this is done. So basically, we cannot provide that information to a third party without the customer's permission. So essentially, the customer has to say either through using the green button, for example. You can download that data, and then it's yours. You can share it with anybody you want. You can also instruct PG&E to send that information to somebody else, but we have to know that you've approved that. We cannot release that data to third parties without your permission. Yeah.
You said there was, so our smart meters have 2 wireless communication devices, and so all the ones that you've installed have those 2?
Yes.
So we could actually, just with our smartphone, be able to read something off this?
You need something in between, but actually one of the devices that we have. So first off, the radios are installed. They haven't necessarily been turned on. So the radio that has been turned on is the one that's pointing back to the utility so that we can communicate the data back and forth with the usage. The radio that's there for the home area network application needs to be turned on. So there's a process that's kind of turning that on, which we can do remotely. And then you need a device that couples with that.
What's the format that you use for that?
The communication protocol is a Zigbee. 1.x is kind of where we're at. We're trying to get to a 2.0 that has better security in it, but it's a Zigbee. One of the devices that we have that is can couple with that radio. It's a display device. It's a portal that you can actually it can push out onto the internet, so you can access it remotely via the internet, or you can get to it via a mobile device. So you can get to it through your smartphone, but just not directly to the meter.
So Zigbee, basically a Zigbee gateway through Wi-Fi.
Exactly, right.
Okay,
And then you can do that, right.
Awesome. I didn't realize it had all those features.
Right. Well, it's still kind of in the pilot phase, and we walk through that, but
Turn it on, just give them a call.
it's on our PG&E website. There's a set of approved devices that you can go buy, and you can go buy them. You call us up. There's actually a form you fill out and kind of let us know what you want to do, and we walk you through the process of how to enable that. Question over here, Ron.
Kevin, can you talk a little bit about your R&D agenda for the next few years? This is an R&D institution, and it would be nice to hear about some of your plans for the future.
Okay, well, so I had a slide earlier that kind of talked about some of the pilots that we're doing. So that's really more on the demonstration end of that. So these tend to be more commercially available products, and what we're looking for there. So it's part of our agenda. It is to understand what the benefits are for our customers before we actually go and deploy on a large scale. So it is really understanding up front that you can in fact get when you reduce voltage by 2%, that you actually get a 2% decrease in your energy usage on that feeder. So it's kind of the one level of that is just testing this technology and proving out that it really works, turning that into a business case to say we should or we should not expand beyond that. The other part of the agenda is really dealing with some of these types of things. I mean, we touched on it a little bit. What should we be doing with respect to energy storage? What are some of the other ways in which we can deal with the renewables, intermittent renewables, whether it's better forecasting? I mean, there's constantly, lots of opportunities for improving our forecasting. And then the other area is kind of with respect to both the customer side as well as the grid side, and this whole idea of data analytics. And what can we do with those data analytics to provide better value for our customers? So one of the things that we're actually looking at is using smart meter data to and again taking that data, using analytics to kind of slice and dice it to actually allow us to do almost a kind of a bill disaggregation or a load disaggregation to help customers figure out, without knowing more what's actually going on inside their home, but could we better help them understand how they could save energy? So almost doing a energy efficiency consulting service over the phone by pulling up their data, kind of using these analytic tools to help them figure out what are some of the ways that they can improve their energy usage just by slicing and dicing the data. And the other is using that same kind of data analytics for grid operations. So taking data about our SCADA information, or our information about our grid operations, comparing that to maintenance data, comparing that to weather data, comparing that to fire risks, kind of mashing that together to figure out, well, what should we be doing with our assets to help us make sure that our system is safe, that it's more reliable, and kind of using those data analytics. Those are a couple of areas, but they're in the category of renewable integration, grid modernization and optimization, and customer service and enablement. Those are the focus areas. Okay, another question?
Yeah. Yes. Here. Yeah, you showed a graph showing when many residential solar comes on, how the voltage is changing.
Yes.
Does it mean in the future you're going to restrict, there is a limit on how many homes can come on to the grid and that kind of stuff, how much megawatt can come on to the grid? If I wait long enough, would I not be able to get on the grid with a solar panel?
Great question. And depending on where you are in the country, that is an issue. That utilities in some cases have established a limit. So you can only have 15% of the peak demand can come from distributed resources. What we're working on is a couple things. One is how can we mitigate this type of problem that might be limiting, and this is not the only issue. We have other concerns with respect to safety and some of our protection systems. So what can we do to make the grid maybe more resilient so we can accommodate more renewable resources safely and reliably and not have some of those limits? The other is what are some of the things that we can do with those inverters to help the inverter participate? Because today the inverter is designed to deliver power at unity power factor, and that can create some issues with respect to voltage. So that is a whole area of research and development and standards development that we need to do.
Hi. Congratulations, first of all. A great journey beyond the research laboratory.
We're getting there.
Nice story. But could you tell me, because of the time limitation, one unexpected great things and one maybe bad things, what happening during your journey? One very good things, unexpected great things, and also unexpected bad things.
So I think the one really good unexpected thing that we found was the interest on the part of our customers to kind of manage their data. So right as soon as we made that information available on the website, we had a lot of customers go in and look at that. We were a little bit surprised. We weren't quite sure who would be interested in that, and now again they tend to be the early adopters, but we were pleased that there was as much pull for that information as there was, because we see that there's a lot of value there, and we were happy about that. It was a little surprising. We weren't quite sure that we were going to see that. I think the other issue is I'll focus a little bit on I guess kind of on the areas that we discovered that were maybe unpleasant or less of an issue. And I'll just use our smart meter deployment program as an example. If you're a PG&E customer in the service area, I'm sure you've heard something about smart meters. One of the challenges with being a pioneer is that you may take some arrows. When PG&E was the largest U.S. deployment and the kind of the largest, earliest deployment of these smart meters in the U.S. When we did benchmarking, before we started that project, we talked to utilities all around the world that had done this before, and everything we heard from them was, this is an infrastructure project. All you're doing is you're taking your meter out and you're replacing it with another meter. And the communication with customers needs to be along those lines. We're just going to come, you're going to have a short outage while we change that out. And once you've done that, you can then begin to communicate with customers about all the services and benefits that you can provide. And so that was how we approached it. And clearly, we learned we needed to engage consumers a lot sooner in that whole process, which is why we've now designed this piloting, testing, learning how to communicate with customers, what's of interest to them, how to talk to them about that. So The good news is for the industry that the playbook that we wrote, kind of in a reactive mode with respect to that, is the playbook that utilities are using now around the world is when they go about doing a smart meter deployment and how to communicate with customers and engage customers. So I guess those would be the 2 points. And maybe one more question, and then you need to wrap up? Or,
Yeah, is there a question over there? And then
Kevin, great presentation, by the way. I have basically one question. You talked about the smart grid pilot projects where you're looking at sensors and a number of things. Then you had the EPIC project enlisted as well. So you've got those going on, building a business case. Then you also showed in your slide you had about 200 circuits where you saw improvement, reliability,
right.
reduction of like 800,000 customer minutes.
Right.
Is there any thought about rolling your R&D together with what you've obviously shown with your circuits and such? And I don't want to say acceleration, but obviously I know PG&E has much more than 200 circuits
yes.
throughout their entire system. So
yes.
Any comment to it? Thank you.
So the way I'll answer that is that the system that we're deploying in the case of the 200 circuits, I didn't say we're by the end of this year we'll have 400 circuits deployed. We've proposed to expand it further. We have about 3,000 circuits across our service area. That's commercially available technology. Basically, you can go out and buy that. You can buy that today. Utilities are beginning to do that more frequently. You don't need to do testing on it. I mean, essentially, it's ready for prime time. The types of things that we're doing, both in the pilots and in the EPIC, are not quite ready yet. We don't know yet that we're going to get the kind of benefits that we were anticipating. We want to simulate that in the lab. We want to simulate that in a pilot environment to understand what those benefits are. And also, we know that the technology is often not what it's advertised to be. The sales guys will tell you one thing, and what you actually get is a little different. And also, you have the other issue of integrating it. So we want to test that integration. We want to test those benefits before we move to the large scale. So the idea is actually EPIC is kind of pre-commercial, early stage. You got pilots. The smart grid pilots they're generally ready for commercial, but they haven't been fully tested yet in an integrated environment. And then you've got the deployment, which is essentially what we're already doing with the advanced distribution automation. Hope that helps.
It's 1 o'clock. Thank you for great questions, great answers, and a great presentation. Kevin Dasso, thank you.
Thank you very much.